The churning spiral of a colossal storm emerges from Earth's veil of clouds. It's a tropical cyclone. In an average year, 89 more will follow, and 12,000 people will perish worldwide from their powerful winds, rain, and wave surges. Tropical cyclones may be unstoppable, but they're not unpredictable. And prediction saves lives. Depending on where you live, you might call tropical cyclones by another name. They're called hurricanes in the Atlantic Ocean and the Eastern Pacific Ocean, cyclones in the Southwest Pacific and Indian Oceans, and typhoons in the Northwest Pacific. But they're all the same kind of storm. Scientists can mimic these storms and other weather on computer screens using mathematical models. Models help forecast where and when these whirling tempests will hit land, and how intense they'll be when they strike. Yet tropical cyclone prediction is a skill that's been evolving for centuries. Centuries of careful observation and scientific theories. Ancient coastal cultures began the practice of storm observation. In the Caribbean, native legends tell of a destructive wind spirit, which some called huracan. People would scan the horizon for signs that huracan's fury would soon arrive. Hot, sticky air, swelling ocean waves, and a fiery red sky. Depictions of huracan feature a central head and two lashing arms, the very likeness of a tropical cyclone spiral structure. By the 16th century, sailors were logging observations right inside tropical cyclones. They braved ship-splintering squalls to chart storm locations and measure temperatures and air pressures with basic instruments. Yet the observational record was still too sparse to see distinct patterns. To predict where tropical cyclones would strike land, forecasters needed many more observations. By the 1940s, a fleet of new devices was tracking storms worldwide and recording their temperature, pressure, wind, and other conditions. Finally, patterns were becoming clear. You can see some in this storm track record from 1950. Tropical cyclones always begin in tropical waters. They often move westward. They gain strength over warm waters and lose strength over land. Forecasters began using the patterns to issue warnings, but predictions weren't terribly accurate, leaving citizens in doubt. As the 1960s dawned, two revolutions in technology would fundamentally change the nature of storm prediction: satellites and computers. Today, satellites track virtually every tropical cyclone from space. With plenty of observations from aircraft, buoys, satellites, and other devices, scientists now have a solid theory of how tropical cyclones work. Warm ocean waters simmering under a cluster of thunderstorms fuel its growth and organization. Earth's rotation spins the storm. Prevailing winds steer its path. Inside the cyclone, warm, moist air pumps from the ocean to the atmosphere, like steam from a teapot. The warm, moist air rises because it is lighter than the surrounding air. As this lighter air rushes higher in the atmosphere, its water vapor cools, condenses, and releases as rain. Around the edges of the storm, where the air is heavier, the higher air pressure forces more air to spiral toward the storm's low-pressure center. This air rush fuels the storm's whipping winds. A tropical cyclone can die if another weather system breaks it up, or if it loses its warm water fuel by reaching cooler ocean or land. Today's scientists use the stream of observations from the atmosphere, ocean, and land, and the theory of storm development to predict a tropical cyclone's next move. The process is so complex, it requires supercomputers. Scientists create computer programs called weather models and climate models, which divide Earth with a three-dimensional grid. The program instructs each grid cell to obey the physical laws that govern the interactions of Earth's atmosphere, ocean, and land. Just as these complex interactions can produce tropical cyclones on Earth, they do the same in the model, like in this model prediction from early September 2008. Scientists then test the accuracy of the model by comparing its forecast to actual weather events. The white clouds are real satellite observations from the same time period. You'll see similar patterns in the real clouds and the clouds produced by the model, even similar tropical cyclones. When a computer model accurately reproduces weather from the past, it is considered reliable. The model can then be run forward in time to predict a tropical cyclone's progress days in advance. Some types of models are starting to warn of periods of severe storm activity weeks or months ahead. Climate models can project years, even decades into the future. They are essential to gauge the influence that climate change may have on tropical cyclones. No computer model will ever be a perfect crystal ball, but their predictions help us plan ahead, to see future storms, to save lives.